SHOT was an acronym, originally was an acronym that stood for Sharpless, Holden, Pasquarelli, but we actually took our names off the firm about 4 years ago, and it's now just SHOT. And there were 5 partners that founded the firm, even though it's 3 names, which confuses everybody. So we made this chart to explain it to everyone. So all 5 of us went to Columbia, and so that's the year that we graduated with our MArch degrees. And if you're in the green bar, it means that you're married and share things like bank accounts. And if you're in the sort of light gray blob here, you're identical twins and share things like genetic code. The partnership actually started when Bill and I were housing partners, which was the one semester at Columbia where you had to work in teams of 2. And I think one of the other interesting things, as I also mentioned, is that all of us had other careers before we went into architecture. So everything from fine arts and engineering and into actually even investment banking. And I think that it's actually part of what we try and actively recruit at the firm, and here are some of the people that work at SHOT, and that we really try and look for that kind of diversity and a kind of open think tank mentality to try and bring other methods of problem solving from other fields into architecture. And you know, the firm has grown quite a bit. It started with the 5 of us, and as of 2007 we were about 65. We actually grew to about 80. We're back down to around 60 at this point, and hopefully getting back to 80 very quickly. But you know, the 5 of us didn't really have sort of like a common stylistic sense. We really were, I think because we came from other fields, we were a little bit confused, especially sort of in the late 80s, early 90s in architectural discourse, and the way in which architecture had been divided in the second half of the 20th century between sort of paper architects, the people that were producing culture and thinking, and all the fantastic design, and the kind of service architects, the people that could actually put buildings together and knew how to get things done. And you know, they basically told us in school you had to choose one or the other. And that was really a kind of horrifying thing to us. We didn't understand why you had to choose one or the other. And I think at the same time, there's this sort of, you know, moment where we were trying to understand, again, as outsiders, this kind of, you know, cycle of stylistic consumption that architecture had become obsessed with, where, you know, there was a new theory, it came out of writing, history, whatever, then it sort of got a kind of form attached to it, then it got its big show at MoMA, then it sort of was popular and made it into the New York Times, and then it was discredited, and then it was out of fashion, and it was ridiculous to us. And you know, to us it just, you know, was about as meaningful as this. So, you know, I think that the reason the 5 of us came together was that we felt that there was something more interesting, and that we wanted to see if we could make a both-and firm. A firm that could be well-versed in cutting-edge theory, could really push design, could push what architects could produce as part of culture, but also actually knew how to put the buildings together and could service the clients and could build at very large scale, at various scales, including large scales. And I think that one of the key things was that, you know, we wanted to move beyond a kind of style, and so the way that we started to look at things was really looking at this idea of performance-based design. Design that wasn't coming from a kind of image, but really trying to figure out how buildings worked and what they did and how a form could influence those things. And, you know, this is sort of like 1996, and we were really looking at aerospace and the automotive industry as the places where, although certainly not perfect, but where performance-based design was the most engaged as a kind of thinking and a way of making that relationship between form and performance. And of course, the most classic place that performance-based design succeeds and fails is in nature. But we started to get this relationship down where we started to get kind of excited because we realized when things worked well, they also sort of looked good. And that was kind of exciting to us, that you could start to think about buildings in that way. and really began to kind of use the emerging digital technology in the mid-90s, which was kind of fast enough for us to begin to do simulations to really test if form and performance had a strong connection. Of course, we looked at the history of architecture and the production of material and form and ornament and its connection to technology, and we saw these long-standing relationships. And even though at that time the sort of output from these experiments was often complex form, and there was this incredibly long history of complex form in architecture, the key thing was that when complex form was making things this way, it was all based on labor. And materials were expensive and labor was cheap, and so you could build in one particular way. But in the latter parts of the 20th century and currently, it's labor that's expensive and materials that are cheap. And so very early on, we realized that the only way we were going to try and get some of this built, especially as a young firm that wasn't going to kind of command the budgets that more established architects would get, would be to take advantage of CNC technology. And so in 98, 99, 2000, we decided to sort of invest all of our thinking into CNC technology and to start using the computer as a way to fabricate this and to try and get towards the idea of mass customization. And now one of the things that we started to realize, and I'll show it to you as we kind of go through some of the projects, was that the notion of plan, section, and elevation really to us became a kind of limited language. And that there's something that we're really trying to challenge there, and that a lot of the investigation and research of the firm has gone into the idea of reevaluating if that's the best method for us to sort of get our ideas across to the people who need to fabricate and build buildings. And so for us, it really was never the form that mattered. It was how something was made and what it did that mattered to us the most. And so whether that was, and the more we sort of pushed into this realm, the more that we realized we were kind of just going backwards in a way towards a kind of master builder sensibility, if you will. And so whether it's a few of the bricks from Brunelleschi's dome or 3 of the 4,000 custom pieces of zinc we made for the porterhouse, we realized that there were territories that had been given up by architecture over the past 30, 40, 50 years, and that it was time for us to start to grab them back and take responsibility and take risk and rethink the way in which architects could practice in order to push the limits of design. So this is the only drawing in the AIA documents. And we have determined that this is the worst drawing ever made in the history of mankind. And this is a drawing that is made by lawyers to try and make architects and owners and contractors fight in order to force them to have work for the rest of their lives. And I'm not kidding, I'm not being facetious. And so I think that a lot of the way we've started to really push practice in thinking about it was to really try and challenge this diagram. Now, obviously, it's very entrenched. There are a lot of things that you have to watch out for as you do it, but I think step by step, and what I'll show tonight is 6 or 7 projects that just talk about how a young office sort of tried to grab these things and just in each project take sort of one little step with sort of R&D that both pushed the architecture, pushed the technology, and pushed this kind of structure behind the way in which things get made. So very early on, I mean, I think the earliest one and kind of the most obvious way to start was absorbing the consultants into the design process. Now, of course, I mean, we're bringing the engineers in and the mechanical and the structural guys, but it wasn't really that. It was actually bringing the fabricators and even the subcontractors into the office before we would even design anything. So, by saying, well, if we want to make something out of metal, let's bring metal workers in. How big are the sheets? How do you fold them? How do you clip them? What are the 8 ways I can bend it? What makes a bend expensive? What makes a bend cheap? How many sheets come in a package? And all those kinds of parameters were things that actually got fed into the design process before we ever sketched what we thought the building would be. And I think that that was a kind of attitude that we took right from the beginning that actually you'll see drove a lot of the work as it went forward. So Isla mentioned PS1, which we won in 2000, the summer of 2000. and I'm sure everyone here is, or most people are familiar with this competition at this point. The year before we won it, a young architect named Philip Johnson won it the year before we did it, and which was interesting. And then they came to us, and I think they got about 2,000 people per weekend out to PS1 for this party that's called Warm Up. And then Alana Heiss, the director of PS1, and Terry Riley, who at the time was the architecture curator at MoMA, said we should use this as an opportunity to let young architects experiment in the spirit of the sort of houses that were built in the garden at Museum of Modern Art. So our program was an urban beach, and the first question we said, well, how would you think about that performatively, and do you need sand and water in order to have an urban beach? And so we said, not really. If you had sort of shaded areas, places to change, places to sit, places to move and dance, and places to get wet, you would in fact have a beach. And so the idea was to take a series of surfaces and just mutate those surfaces so that the program could evolve along those surfaces and the spaces that it captured. Now, the other thing that we thought was interesting about the performative nature of a beach was the idea of the promenade. The fact that you either sit on the beach and you watch everyone walk by, or you go for a walk and you look for your friends, and there's always that interaction that occurs on a beach. So this is the courtyard at PS1. Here's actually the museum. You enter here, this is the ticket booth, and then you go up these stairs, and that's actually the front door, and this is the sculpture garden. And so we placed the architecture in such a way that the people hanging out at Dunescape during the day were the people who were sitting on the beach, and the kind of unsuspecting museum goers passed through the architecture in such a way that they became the promenaders. And we had 3 weeks to design it and 3 weeks to build it, and a budget of $50,000 for an 8,000 square foot space. So we said, well, we better make it simple. It's the only way to do it. And so we said, let's take just one structural element, which were 2 by 2 sticks of cedar, and we set them up in an AB configuration, the connection point being the spline that we pushed and pulled in order to make the surface bend and move in order to allow every one of those programs to unfold on the surface. This was the sort of first sketch of that. These were the early models. This is actually the model of the element. The reds are the A's, the blues are the B's. And Alana Heiss, she was a great client. She said to us, I'd like you to produce an architecture that encourages as much illicit behavior as possible. So we said, well, what do you mean by that? And she said, I'd like people to take off their clothes and smoke as much as possible. So we actually embedded huge ashtrays right into the thickness of the walls themselves, and all of the dimensions were all taken for dimensions of the human body, which were meant for people to overlap and continually touch while they were involved in the architecture itself. Now, this is the construction drawing set. It's not out of focus, and each one of these drawings, here's one blown up, was 15 feet high by 30 feet long, that were put down as full-scale templates, and you basically just followed the colors in a sequence, and you followed the black lines, and you lined up the two pieces, and whenever they crossed, you hit it with a stainless steel screw, and you trimmed off the two edges, and the Z coordinates are down here in the bottom. And so you could see the pieces going together very quickly and inexpensively. And then we dug in the courtyard, and we planted a forest of steel trees that had high-pressure mister heads on the top. And here's the Dunescape when it was finished. And then about every 15 or 20 minutes, they would blast and fill the entire courtyard with mist, which was, as you were lying there baking in the sun, would be the sort of spray off the ocean, and would hit the cedar and wet the cedar and give this incredible smell to the whole courtyard. But here you could start to see the kind of smooth transition from a bench to a wall, or from a kind of shaded area to a pool. This was the night before the opening. They gave us the courtyard for one night, so we filled the pool with beer and had our own party. And then these were some of the interior spaces. The other thing that was also very interesting was we developed a series of secret chambers inside the thickness of the structure itself that were designed for 2 people at a time or 3 people at a time, that you could crawl inside and you could see everybody at the party, but nobody could see you. They were unbelievably well used all summer long. And this was a typical day at Dunescape. And the interesting thing that happened was we got a lot of press from this, and people were excited about the architecture. And we had so many articles that it actually drew more than 8,000 people per weekend. And sort of as the summer was winding down, I was kind of sitting there hanging out, and I said, that's interesting. 6,000 additional people times 10 weeks times $10 admission plus 3 beers and a hot dog or hamburger average, and suddenly I realized we generated about $1 million in additional revenue for the museum that year, and our fee was $12,000. And I said, something's really wrong with this architecture thing. We've got to try and fix it. But I think that there was something very interesting that happened at that moment for us, and that was we finally felt free of the kind of modernist canon of the separation of structure, skin, and program. And actually, we started to get very interested in the notion of thickness. The idea that surface, structure, and program could be blended into a single thickness that could be mass-produced and mass-customized, if you will. And it's really still the idea that's pushing a lot of the work that we're doing in the office today. So from a very little project, it's now working on projects that are anywhere between $500 million and $1 billion that are currently in the office. And so, talking about that journey, I think that there were certain things that we did learn that we applied for some other little projects right around that time. Richard Branson saw PS1 and asked us to do the first-class lounge for Virgin at Kennedy Airport. The idea is that typically a first-class lounge is behind a closed door and you never see it. And the idea here was to make a first-class lounge that was almost a billboard, an aspirational billboard, if you will, that you could see, you couldn't really get into, but it might encourage you to buy upgrade to a first-class ticket. And actually, it's funny, I just saw this morning for the first time in a year because I took Virgin America out this morning, and I knew something was missing. They removed that part. Anyway, the thing is, you check in over here, and you can see right through the screen out to the runway through this lattice work that holds the lighting and the structure and all the forms. But as you move into the space, a kind of moire pattern emerges that gives a certain intimacy to the spaces themselves. There's a waterfall and a stream that sort of blocks the sound qualities of the airport from being in the... Can you see that? Yeah, you can. So again, this was one of the first times that we really got into developing nesting drawings for the mill to fabricate pieces. All the parts were made into component pieces that could be delivered to the airport and assembled in a certain sequence that would get us around a series of rules with the Port Authority. And there's a whole lighting system that goes from yellow to orange to red that's timed with when the flights to London are leaving. So the redder the whole space becomes, the faster you have to run to the gate to get there. It also brought us to a project that we did outside of Seoul, Korea. It's called the Hangil-sa Book House. Hangil-sa is sort of like the Rizzoli of Korea in a way, and it's part of the Harry Valley Arts Complex. So you actually come off the hillside up here and enter the building at the top, and then you walk down a ramp around a 3-story high wall of books that are the bookstore itself, and come down into a kind of restaurant and cafe space. And there's a sculpture garden here. And we prepared all these drawings, and it got fabricated in Korea and assembled like a kit, and it worked pretty well. Here you could see the bookstore as you come down and you move around. and sort of what the building looks like at night. But the more we were getting involved in this, the more we started realizing that there was a lot that we were doing with the contractors and the CMs to actually get this stuff built. So on one project, which is Mitchell Park, which was a competition that we actually got third place in, but eventually got the commission to do, which was out on the eastern end of Long Island, so about 120 miles from New York City, in a sort of rural fishing village. They had a 4-acre open spot. This is Main Street, and that's Front Street there. There was a big open lot, and they held a competition to build a park. And they had a series of programs that they suggested, but really there were only a few that they insisted upon. And the key one was a carousel. The town's prized possession was an antique carousel that had been given to them by the Grumman Corporation in the 60s. And it sat in a Butler building right here on the corner, and they charged $1 a ride, and they got about 1,000 rides a month. And so they wanted a new carousel house in the park, and of course they wanted it to be a Victorian carousel house. And so we came up with a series of diagrams, and we came up with this idea of sort of, it's like almost like a chain that went through the middle of the park, a necklace, and then all the programs sort of linked off of it. There was an amphitheater and the harbor walk and a shade pavilion, and there was a water garden here that turns into a hockey rink in the wintertime, and some playing fields. And then this is a ferry terminal. And then there was a folly that the town also wanted. They wanted a camera obscura, but I will talk about that in a minute. So we worked on it. Here it is. It actually took 8 years from start to finish. We eventually we wrote grants for the town. It was built in 3 phases. We did soil remediation ourselves. We got licensed to actually do soil remediation in the state of New York because we couldn't get anyone to do it. And we built this carousel house, which was made of 16-foot high by 16-foot wide bifold steel and glass doors that actually work on a worm drive and respond to the local weather patterns on the site. So as the prevailing winds are coming off the water, it closes down. On hot days, it opens up. In the winter, it's completely enclosed, but it can operate all year long. And just by writing the performative rules of what this piece was, we actually convinced the town that this was, in fact, a Victorian carousel house. Here's the ferry terminal and the harbor master's house. You can see the water garden in action over there. Here's the water garden at night, and the shade pavilions where they have farmers markets on the weekends. And then in the wintertime when it turns into a skating rink. And then the last piece that we were going to make, and as we said, we started this project in '97, and this was now about 2000, well, we started working on this maybe in around 2001 or 2. I mean, I think the idea for the camera obscura was to really push it. Here was a building, we sort of learned enough about using the technology, and it was a small enough building, and we had gained enough trust with the client that we really wanted to push it to see if we could make a sort of pure performance envelope and see if we could have the entire building fabricated by the computer. So there was a certain series of programmatic requirements. We tried a kind of minimum surface form. And this was sort of BIM version 0.01, where we kind of just modeled every single piece for the building. And these are the construction documents. And so in 3D, we kind of cataloged and indexed all the different material types so that you could see where they went. And then there were basically 2 kinds of drawings in the set. There were drawings that explained to the computer how to make the parts, and then there were drawings to the contractor how to assemble them. And you know, we basically produced the whole set, and when we were done, and these are the actual CDs. There's nothing, these are not presentation drawings. These are taken straight from the set. You know, fold, weld, bolt, screw, you know. And the interesting thing is we were finished with it, and we looked, and we realized there were no dimension strings on the whole set of drawings, because they were totally irrelevant. every single piece arrives on site, pre-cut, pre-numbered, pre-drilled, ready to go and put together. In fact, the worst day on the construction site was Mark Hours, one of our guys, was out there, and he heard one of the contractors start a saw, and he just ran out of the, don't cut anything, because he had actually just picked up the wrong piece and it didn't fit, and he was going to trim it to make it fit, but there was no saw needed, and in fact the contractors didn't have tape measures on their belts for the whole process because they were irrelevant. And so here are even some of the drawings. You can see the equipment making the pieces, even the templates. These are the flanges on the compression ring, and we laser cut into the parts, instruction sets on where the welds go, which piece lines up where. It was all there to make them look at the drawings as infrequently as possible, and just be able to build it like the most kick-ass piece of IKEA furniture you can imagine. And even the formwork was all milled as well. So the surveyor just shot 4 locations and then full-scale templated out. They dug the hole and assembled the pieces. And I think it was 4 guys built it in about 7 or 8 weeks. And the piece went together. And that's sort of the interior. And it was a really phenomenal thing for us, because we realized for the first time that, okay, there's something here. You can actually build buildings this way. And I mean, no one is ever suggesting that you build a 45-story building like this. That's not the point. But what you can do is you can find the critical parts of your building that you're working on, and you can invest a tremendous amount of time into thinking about how to do things this way. And then a lot of the rest of the building can be built in very standard methodologies. But you could really see that this was something that was going to pay off a lot for our profession into the future, and gave us a lot of confidence to move forward into larger projects. And this is kind of what the whole park looks like now. There's the camera obscura out at the end. So we started realizing that we were really doing a lot of good things for our clients, and so and making the money. Well, the last thing was that on the park they were getting 1,000 rides per month, and now with this new Victorian carousel house that they love so much, they get upwards of 50,000 rides a month in the summer, and it's actually up to $2 a ride now. So it's generating hundreds and hundreds of thousands of dollars for the town, and they've planted flowers up and down the whole main street, and their real estate market's gone through the roof, and is even held on in the downturn. And it's not a surprise. Mayor Capel, who really spearheaded this whole project, is also the town's biggest real estate broker, and so I think he was pretty smart in using architecture as a way to drive desire. So with that said, we started thinking, is there a way that we should start to team with our clients, where if we're coming up with all these ideas that are solving problems and turning design from a cost center to a profit center, should we begin to joint venture with our clients and be able to take the risk along with them? So the first time we were able to do that was a building called the Porter House in the Meatpacking District of New York, and there were 10 developers fighting for a 6-story warehouse building, turn-of-the-century warehouse building, and the owner was trying to sell it and obviously wanted the most money for it, and I think that everyone was trying to think about how they could raise their bid to get control of this building. So there were 2 smaller historic buildings to the south, and this building was built to its full FAR. And what we said was, and a lot of guys, maybe 7 out of the 10 developers thought about doing the air rights transfer. Now, there was a height limit in the neighborhood, and there's also a setback requirement from the street. So, that was the sort of first thought, but of how much air rights we could transfer. But then the sort of next idea was the only way to increase the size of this addition, and therefore the potential revenue down the road, which would give you a little bit more money to outbid the other developers, was to cantilever over these 2 historic buildings to the south. And then working with Bureau Happold, our structural engineers, we really came up with an interesting way of moving the core, which became the kind of new reinforced beam, and we put a sort of 3-story Verandil by building a kind of 6-story new building onto the 6-story old building, but overlapping on 2 floors, to in a very inexpensive way, get that cantilever out a little bit further. And just those extra couple feet were enough additional revenue to allow us to be the sort of last guy that could bid the most to get control of the building. So we didn't really have the money to do any of this, but we went for it anyway. And we approached one of our clients and said, do you want a joint venture on this? And they said, yeah, it's really interesting, Jeffrey Brown. And so we were going to take this new box and put it on top of a historic building. And I think that we really wanted to push the idea of what contextuality meant. And our feeling about contextuality was that it shouldn't be contextual at all. So we took an idea where we said, let's make a zinc. We wanted to use zinc, and we wanted to make a metal panel building. We hadn't tried that yet. So we talked to lots of zinc fabricators, and the prices were ridiculously expensive. So what we did was we actually went to France, and where they make most zinc comes from, and we bought 1 meter by 3 meter sheets of zinc, about 1,000 of them, and we designed the panels in such a way that sort of 1 unfolded sheet fit on a sheet of raw material, or 2 sheets on a sheet, or 3 sheets on a sheet, 3 panels on a sheet. We took 4 window sizes, all the same height, floor to ceiling, and then we had these 2 light boxes, a sort of thin one and a thick one, and it made about 22 protoforms. And we then played around and wrote an algorithm to sort of spread these panels and pieces all over the building to almost make a kind of cloud that sat on top. And one of the key things that we felt was that, you know, for us, when you're doing metal buildings, sometimes when the glass and the metal are in the same plane, it gives a kind of thinness to that facade that we didn't really like. We really wanted to have sort of depth and texture. So we ended up pushing the glass back 14 inches everywhere on the building, which of course immediately made us think like, well, we're going to have ledges everywhere, and in New York we have pigeons everywhere, and so we figured we're going to have a huge pigeon problem. So we actually called the Museum of Natural History and asked them if there was an angle of repose for a pigeon. And they told us that, in fact, if you had something that was 34 degrees, a pigeon would land on it and slide off the edge. And so if you look, there are these panels in front of every window that have a 35-degree slide on them. Now, at the end of the day, there were 4,000 different pieces of zinc in over 480 unique shapes. So to draw all of that in shop drawings would be impossible, right? It just, you couldn't do it. So this was the first time we played with SolidWorks, and we just drew the kind of panel prototype and then just fed all the difference in the spreadsheet, and it went directly from this spreadsheet to the laser cutter to cut all the parts. So there were actually no shop drawings made whatsoever. And so all the panels got labeled, and that was laser cut right into the facade. And that was the instruction set as to where the pieces would go on the building, where they would lay out as it was getting built. And here you can see the facade as it's going on and what the building looks like today. And so we started at that corner, and we kind of went all the way around and came back to the other corner, and we were 1/32 of an inch off after putting 4,000 pieces of zinc up. So again, we were like, okay, this stuff works. This is a good idea. And they were condominiums, and we did everything. We did the interiors, we did the collateral materials, we did the lobby. Here you can see the cantilever portion of the building and the setback terraces and the pigeon slides, which were labeled PS and then their number. And it's just going forward. Oops. You can see the kind of depth in the paneling. And we designed all the collateral materials. We brought them to market and sold them, and it's a retail space in the base, and it's 22 units above. And this is how the light boxes, so this is from the day tonight. And it's actually a funny story. Jason, are you here? Jason Anderson? Were you there the night we all went out drinking? We turned the lights on the first night? Yeah, oh yeah, sorry. But there was one I remember, which was we all went out after, I think, a softball game, and we went to the meatpacking district, and we all went out, and we called them, they flipped the lights on, and they went on, and we, were like, hooray, and, stayed out till 4. And the next day, I think I woke up with a really vicious hangover, and my lights weren't going on in the apartment, and it was the blackout that had hit the East Coast that night. And for like 30 seconds, I was just like, I hope we wired that thing correctly. But that worked out very well. And the interesting thing, and here was the amazing thing about the Porterhouse, which was when we were going to do this, a lot of our colleagues, my fellow professors, a lot of our friends, they said, don't do that. You're going to get in bed with the developer. You're joining the evil empire. You've gone to the dark side. It was really, we were sort of threatened in a lot of ways. And actually, it was Bernard Tschumi who we went to for advice and said, don't believe that. You should definitely take a shot at it. And the fascinating thing was where everyone was sort of telling us, like, this is going to, you're going to compromise your integrity and you're going to be stuck in bed with the developer and you're not going to do. In fact, the exact opposite happened. As soon as we had, as they say, skin in the game, the developers never asked us or questioned our design moves again, because it changed us from this kind of relationship to this kind of relationship. And they knew that we weren't going to make stupid moves that were going to cost us and to be quite frank, we had a lot more at risk than they did, because these people have money and we didn't, and we had just a little bit that we were trying to get a little bit more. But the fascinating thing was it completely changed the nature of how we worked with our clients. So much so that we've now done it more than half a dozen other times. And in fact, by taking that risk and understanding the financial models, the fabrication models, the aesthetic models, the theory models, the selling models, we actually gained so much in our design freedom. And it was exactly the opposite of what everyone had told us at the time. Another project where we're doing a similar thing is a building on Houston Street that's actually under construction right now. We bought this little building in this empty site, and this is the Puck building. So this is actually the last corner in Soho, and this is the first corner in Little Italy. And Little Italy has a code about, sort of window openings, and the key thing is that every building has to be masonry. It's a historic district. And we were like, oh my God, what are we going to do with bricks? So we kind of tried to think about what could we do with bricks. And the idea that we came up with was, could we begin to use the fabrication techniques in order to make custom formwork that we could drop bricks into and do precast panels where the custom formwork, you could get any sort of position of the brick in the X, Y, and Z. You could pour the concrete on behind, and you could lift it out and get any shape or placement of the brick in the panel that you want. So, we studied tons of different brick patterns and overhangs, and worked on software that we were able to analyze different sort of panel shapes and the way in which the panels and the sort of sine curves would match or not match or come together, the orientation of the brick. We looked at ways of, using what were the requirements of sort of the window sizes and the setbacks and the building envelope, but try to make the least number of eccentric panels versus standard panels possible. And it really kind of developed this interesting feedback loop that we were able to sort of really drive the design out of, including how big were the panels that what was the biggest panel you could fit on a truck that could get into Manhattan, could get through the tunnels and the bridges into Manhattan without special permits? How many panels could you make to have a less expensive crane with a swing arm with the least number of picks to get the panels onto the building? And all of that really drove a lot of the design. So these were the test molds. So this was the CNC milled mold, and then this was the test of dropping the bricks in and pouring it, and some of the earlier renderings. the kind of what we thought the building looked like. And then here were the first panels as they came out. We picked this sort of chocolate brick with dark gray joint, mortar joint. And this was in the summer with the panels going up. This is probably October or November. And it looks pretty cool. and then this is the side that doesn't count for it's only the facades on the street line where you have to follow all the rules. So people have these balconies, and then there's this 3-story high glass staircase for the penthouse. And this is kind of interesting. There's actually a kind of small rule in the New York City Building Code, which is a certain percentage of your building can actually go over the property line, which was put in place in order to get detail, like cornices and window surrounds. And we were actually able to calculate it to the brick, exactly how much of the building was going over the property line. And by giving the building department that much detail, we were actually able to push out the entire perimeter of the building by 6 inches. Now, that doesn't sound like very much, but the fascinating thing was that 6 inches times the perimeter of every floor times every floor gave enough additional revenue that it actually paid for all the custom molds. So in fact, that was free compared to just doing a straight panel system. And I know it's incredibly nerdy, but we get really excited with that stuff. Other times, we've sort of worked as an advisor to our clients. A competition that we did back in 2005, in fact, how I met Isla, way back in her Tulane days, was to do a new building on the campus of Tulane. This was going to be the Murphy Institute. It was attached to an existing building, which was one of the only buildings that wasn't orthogonally oriented to all the other buildings on the campus. And the things that we noticed about the campus was that it was incredibly flat, had this very thick tree canopy, but almost no shrubs whatsoever. And that really struck us. And so I think that the idea of the project was to float as many of the classrooms in the tree canopy and keep as much of the ground plane open as possible. And then look at the ways that New Orleans had always dealing with its sort of geometric anomalies. And then we used some of I know it's a little bit hard to see, we used some of the same techniques that we used at PS1 in order, it was an ethics, economics, and philosophy building. Is that right, Isla? The Murphy Institute. And Reed and Isla and Martha had all said to us, they wanted a building that was going to get people talking to each other from different programs. So we kind of used these structures in order to kind of encourage cross-disciplinary pedagogy and interaction. And this is actually the historic building with an atrium carved out, and this is the new building behind. The students can move right through. Here are the classrooms and the big lecture hall, and the students move through over here. And these are some images from the model. And we were really excited about it, and we were fortunate enough to win the competition, and spent the summer sort of negotiating the contract, and we kind of came to an agreement right around mid-August of 2005, and we were supposed to go down there right after Labor Day, and then Katrina hit, and we figured that the model had floated away somewhere, which was down there. But about 4 days after Katrina hit, Martha Murphy, the donor, called us, and she said, I live in Pass Christian, Mississippi. All my homes were destroyed. I'm living in a trailer, and we need some help. We need someone who knows how to get something built. Will you come down there? So we said okay. We went down. This is Pass Christian on day 7 after the storm. So that's Main Street, about a block off the Gulf. That's Martha's house, and it was a fascinating thing. So we went down. Chris Sharpless and Craig Schwitter. Craig Schwitter's the head of Bureau Happel, New York. No one believed that we would actually camp. Yeah, I'm from New York. We don't know how to camp, and so they made us take pictures of that. There's Craig talking to everyone. And, you know, Craig was one of the guys who was on the pile the night of 9/11. He was one of the 6 engineers that was asked by the city to go help the guys take the steel down as they were still trying to do the rescue efforts. And we did the first piece of infrastructure that got built at Ground Zero, the Rector Street pedestrian bridge. And, I mean, it's terrifying, but there was, you know, between FEMA and the Red Cross, I mean, no one really knew what to do. And the fact that we had worked on 9/11, albeit in the most sort of superficial way, suddenly we were in charge because we had actually dealt with a crisis before. And a lot of the government officials were told, well, we really can't do anything. And they were great people that wanted to help, but were instructed not to help, which was a fascinating and eye-opening experience for us. So Martha owned this piece of property. It was covered with woods, and it was right across from the elementary school. It was over here. And she said, you know, I want to build something. I want people to think that there's still going to be a town here someday. And we had no idea. There was no electricity. We were sitting in the tents at night. And so we just said, okay, we'll build 2 10,000 square foot sheds, and we'll put a giant porch on it, because this is so much about porch culture. And the big radical idea that we had that was really hard to convince everyone to do was that we put the gravel parking lot in the back. And they couldn't understand, why would you put the parking in the back? You could put it right in front. We were like, well, we don't want the cars in front, we want them in the back. That was really a struggle. The rest of it was easy. So we made sort of an entryway that you came through with signboards and information kiosks. And then there was this big porch where the town could come together, and we had no idea what would go in there. And Martha said, do something at least cool that will at least, you know, don't make it look like a FEMA building. So we made this roof, this kind of big wing roof. We had very little skilled labor to work on it. They were either working on the big projects downtown or had left. So the way that we were able to get the complex form done was through a series of custom flitch plates that we just had cut in New York and sent down. And there were some of the guys from shop who were, that was the field office. They were amazing and dedicated so much of their time. Reese Campbell and Fed Negro were down there. And we got the Navy Seabees to clear the land and do a lot of the work in exchange for cases of Budweiser, which you had to drive 40 miles to get to sometimes. And here they are clearing the land. And it got built in about 8.5 months. And this was sort of right before people started moving in. I mean, now it has a laundromat, a beauty parlor, a law office, a restaurant. It's sort of the seeds of a town. And there are all lights up inside the sort of wing, and it glows at night. And that was the building, and we got it. It was, and the interesting thing is, it was the first building completed in Mississippi on the Gulf Coast after the storm, and so it was an amazing experience for us. Another project where we worked with a client to sort of advise them on what to do with the city was on the East River waterfront. This was a competition that we entered with Richard Rogers and Ken Smith, landscape architects, and Bureau Happold as well. And we won the competition to do a master plan for this 2-mile stretch of Lower Manhattan, which is mostly underneath an elevated highway, similar to the sort of Embarcadero freeway before the earthquake. But you could see, you know, between the infrastructure, there were some places where there were actually more than 12 layers of chain link fence from where people lived to the waterfront. There's just no access whatsoever. Or these beautiful, this is an 18th century square at Peck Slip that were being used as parking lots. So, you know, the basic idea here was to take all the different neighborhoods and figure out a way to make the sort of cross-grain connections work to get people just access. So we rented a helicopter and flew over all the shorelines of the 5 boroughs of New York and developed a taxonomy of shoreline types. And there were only a few places where the buildings got really close to the water. And so this is kind of where we were. There was sort of a street here where people actually worked. Then here there was almost 120 feet from the last edge out to the waterfront, then a chain link fence, and then usually a shed on the pier. So what we said was, look, if you just sort of get rid of the parking underneath there, add trees, bike lanes, and instead of thinking of the overpass as a kind of big, ugly, dark thing, think of it as a free roof, and build these inexpensive boxes underneath them that you could fill with sort of recreational and community and cultural facilities to make a new kind of esplanade or park where the city actually comes out to the waterfront. So this was a kind of early idea with the glass boxes. We had to build up the planters because there was no soil below, bike lane and sidewalk. And at that time, Richard started getting a lot of other commissions in New York, like the part of Ground Zero. He got WTC number 4, and the convention center. And so then there was a second competition to see who would actually design it and do the drawings. And Richard was like, "You guys can handle it," and I'm busy with other stuff. So we went after it again on our own, and we were lucky enough to win it a second time. And they still didn't understand what would go in these pavilions underneath. So we were like, "Well, look, we don't know either, but it could be anything." So anyway, so we've been working on it, and this is some of the later drawings. This is what the pavilions look like these days. We're in the last months of drawing it, and parts of the package have already gone out to bid, and we break ground in about 2 or 3 months. This is a pier where we double up the piers with a passive recreation landscape on top, also more pavilions on the piers underneath. Here you can see the current design for the pavilions with their operable glass walls, the current planter and furniture designs. There are spots where we're trying to get you down to the water, where we're breaking down the seawall where the historic slips used to be. This is one of the designs for Pier 35. And this is the one part that's in flux. We've tried to peel off, where it gets very narrow, we try to peel this walkway off and do mussel beds, artificial mussel beds in the East River, but the DEC is giving us a really hard time, and we don't know if we're going to get through it. So that part, we don't know what will happen, but we're trying. But it'll break ground, and it'll take probably about 5 years to finish. We got $150 million to build it, and we're underway in about 2 months. But one of the interesting things that happened was right in the middle of this is a large pier called Pier 17, which was a Rouse development, which was the sort of festival marketplace shopping mall guy from the 70s and 80s. And it's just this awful part of New York City that actually no one ever goes from who lives in New York. And the Rouse Corporation was sold to General Growth Properties, GGP, out of Chicago about 4 years ago. And they liked what we were doing in the whole neighborhood, and they said, "Well, will you take a look at our site? We have this 5-acre waterfront site with this shopping, it has a 3-story internal shopping mall on the waterfront in front of the Brooklyn Bridge." Good idea. And so we did look at it, and we said, look, there's a historic building that's up against the highway. We said, it was an old fish market building, move it back and reestablish it at the water's edge. We said, get the sort of network of streets and the esplanade and the view corridors into that space. Fill it with a kind of small filigree of smaller, lower buildings, and then make about 2 acres of open space for a grand piazza that would face the Brooklyn Bridge and the historic ships to the south, and transfer that FAR into a slender tower on top to pay for what actually turns out to be almost 4 acres of public park that would be given to the city. So this is the current plan, and I don't know why that's black, but we'll keep going. So anyway, this is just looking at the pavilions and the kind of roads going underneath the highway. I lost that too. I guess those diagrams died here. These are the shopping pavilions, and we took these kind of wave patterns and wood elements to make these sort of arcs that float across. And one of the things is that you get down to this key corner and you can't find the Brooklyn Bridge, so we carved this sort of slice with this forced perspective that orients you towards the bridge. Well, the diagrams died. And then these are the hotels that float up above, that are they're actually hung from 4 super columns, and then it's a kind of gantry, and the hotels float above the low-lying retail stuff. The idea is to have sort of operable facades. That would be a bifold door that every room would have its own remote control. So from bed, you could operate your shade, which would open or close your room. And every time you would see the hotel, it would be a different configuration. And then the tower, which was the trickiest one, obviously, where we were trying to dematerialize the tower as much as we could. So we started shifting the volumes and separating them, and then the idea was to float the 3 volumes of the building within an exoskeleton superstructure that we would sort of break down the mass. And this is the sort of current design of it. It's steel clad in terracotta. And these were some earlier renderings of it. This is the model for the client. Whoops, lost that one. Let's go back one. So here you can see the whole complex on the waterfront and the tower. There's currently a Geary building going up right behind it. It's under construction. Another view of it. Down the middle part. So we're in the middle of battling for approvals on this right now. The community's actually supported it. City planning supported it. The Economic Development Corporation supported it. We're fighting with landmarks right now, but we think we can win. The big problem, this is one of the restaurant pavilions, and the big problem that we're having right now, though, is that unfortunately GGP stock, which was $67 a share when we started, closed at 45 cents a share this week, or last week, I guess I should say. So they're not really focusing on it right now. But hopefully they're looking for a joint venture partner, and we're probably 85% of the way through the approvals process, and we're keeping our fingers crossed. And then that's one of the piers from the park, and the Esplanade moves all the way through on that spot. So to the sort of last project that I'm going to show you tonight, which was the Fashion Institute of Technology, which was a competition that we entered actually probably 2003 that we won. I know this is very depressing how long all this takes, but FIT is this kind of brutalist campus in Midtown Manhattan, and has all these fantastic programs, but the people in the city can never sort of see what goes on there. Very different feeling from your buildings here. But again, for us, the sort of performative nature of design school, we felt, was kind of exhibiting your work, reviewing and critiquing your work, and circulating your ideas. We felt that if we could make a building that performatively allowed that to happen, we would have a successful building. This is an existing building, and then our site was right here. And the school has 11,000 students, but only 1,000 dormitory beds. So it's really a commuter school. And one of the things that we also felt was really important was having a kind of what we were calling the North Quad, an interior quad or student living room place, a place where you could all get together and kind of see what was going on the campus. And we put it at the 5th floor of the building because that's the floor that all the bridges connect all the buildings to the other buildings on the campus. So you kind of have the outdoor quad at the ground level and the indoor quad at the bridge level. And so again, it was this idea of making this kind of thickened facade that embedded all the kind of circulation, the exhibition, and the critique spaces for the building. This was the model that won the competition. And we won the competition, and then we actually spent 2 years remaster planning their whole campus, and then we spent a year redoing the whole program and redesigning the building. And then we've actually spent the last 2 years both drawing this building and renovating about 60 labs and other buildings to reorganize their space to make enough space so that when we start building this, they can keep the university functioning while we build the new building. But again, a very simple idea where there's sort of two concrete towers, and then it's a very standard kind of loft construction building with all the classrooms, and then there's a large truss that hangs the sort of seminar rooms and faculty offices above, so that the quad is column free, and then there's this one highly specific element that becomes that thickened facade on the front. So all of this is made very simply, except for that facade, which is made exactly like the camera obscura is made. And embedded in that thickness are, again, all the circulation for the building and the critique spaces, the exhibition spaces, runways, and other elements. Oh, we should go back to that. So again, you can see, and then there's a, again, all the projects have a strong kind of sustainability part is embedded in the kind of performance and the way that air moves through this atrium, so that all the existing building portions can still get natural ventilation, even though this building is right up against it, and the kind of current thinking on the facade. And this is the model at the end of design development in our office. Well, I'll keep talking while it waits. So anyway, you can see the kind of escalators embedded in there. That's, well, there you go. Anyway, so again, some of the CFD modeling that was done that helped generate the form. You can see, again, the thickened facade on the front there. That's a view of looking through that thickened facade into the main room. And all of that whole facade is actually hung on cables. This is looking in that sort of north quad, if you will. So it's really almost like a thickened piece of fabric that hangs on the front of the building. And looking west, so we were working on it in October. The state had given the city and the state were 50-50 giving money for it, and the state had given its money, and then with the economic crisis, the city balked, and everything went on hold. But we just found out that it's been part of the stimulus package, and we start tomorrow building it again. So we're hopefully get it in the ground. Well, we have to get it in the ground by November. That is our president's rule. So it will be in the ground by November. Okay, so the sort of ending thing is we're thinking about all of this stuff, and we started saying, like, well, could we just get rid of the client? Would that work? So we started thinking about that as an idea, and it really made us think about something, which was, everybody blames this guy for everything. My laser pointer. You're Italian and you kind of gesticulate, so you do it with a laser pointer in a lecture, and so I killed the battery. But anyway. Everyone sort of blames the developer for the sort of lack of creativity and the kind of thing that we as designers always have to fight against. But it's really not the developer that's the problem. The problem is this guy. That's the problem. Because the developer will build anything that the bank will give them a loan for. But the lender will only give a loan for something, and what they'll say is, I want 5 comps, right? And comps are comparables. And what does that mean? I want to see the 5 other buildings in this neighborhood that are designed exactly like this, and I want to know exactly how much they sold for. And of course, what those comps were what the products were that were available, and those were what the real estate brokers had to sell, which were the only options the purchasers had to buy, which drove the sales data, like, people really like granite countertops. I don't believe that. It's just they only had the choice of granite countertops. And that drives the marketing, which pushes the interior designers, which forces the architect into this horrible position. So, you know, for us, it's like, how do you break that cycle of mediocrity? And I think that a lot of it came from this fact of trying to grab back these territories that have been given away by our profession over the past 30 or 40 years. And it's that we try to make ourselves specialists instead of what we're really good at, which is we're generalists. What we're really good at is knowing a lot of things about a lot of different stuff and synthesizing that together aesthetically and spatially. What we're not good at is being specialists just about image. And we can do it, but it's really a very weak position to be in because you're not taking any risk if that's all that you do. And so the critical thing here is the play between risk and reward. And architects and designers are always complaining that, you know, we don't make any money, we work so hard, you know. Well, it's because if you don't take any risks, you don't get rewards. That's just not the way that it works. And it's not an accident that we're the butterfly flying around the monkey's ass right here. Because that's how we behave as a profession. And the fact of the matter is, until we're willing to kind of get dirty and expand out from just sort of composing images of the outsides of the building, until we can get into the thickness, get behind and past the kind of just the plans and the elevations of the building, learn the technology, learn how it goes together, learn the finance, learn the politics, and bring those things together, we're never going to progress. But the fact of the matter is, our intellectual contribution is the most. We actually do way more than anyone else in the process, yet that little diagram, that little triangle diagram, has relegated us to the side and forced everyone to fight with each other in order to generate revenues for the law industry. And so the whole trick is, how do you move us out of this position? And that's what I'm talking about, sort of doubling down. This idea that the more that we can take what we do so well, which is this wide-ranging skill set, I mean, we do something that very few people can do. We invent something in the future and solve problems three-dimensionally, and then we convert them into a language for other people to then reassemble what we had once thought of. That is a very difficult thing. But if you're only going to do the imagery of it and you're not going to get into the thickness of it, you will never be in the position of taking risk and you will never be in the position of gaining reward. And so that's really kind of what we're making a call to do, to sort of take what we do and do it well. Now, these are 6 buildings that we took huge risks on. And with the world falling apart, you know, some of them we made money, some of them we lost, and some of them we broke even. But at the end of the day, we probably broke even all the way across. But it didn't matter. We got 6 buildings built, and we started to really think about how we do things, and we understood a lot more about the process. And so what I'm saying is that it's not to say that every project that we do or that you do when you go out and practice yourself should have no client. Of course, in different kinds of projects, you have to work in every one of these configurations. And you need to be flexible to think about all those different ways of doing that. And that the idea, though, is to take what we're really good at and expand that as much as you can. And so, I mean, what SHOP has tried to do is we've started, you know, all the real estate stuff that I've talked about. We've started sort of a BIM consulting and construction management company. And we've even started a software company where we're starting to write new kinds of programs for what future designers are going to need in order to sort of get into that thickness. Some of these might be successful, some of them might fail, but it doesn't even matter to us. It's part of a think tank and it's part of an attitude of expanding what we can do as designers to really play a bigger role in the way space gets made. And so I'm not calling for like a new style or a new period or a new theory or a new philosophy. But what I am calling for is it's an amazing time to be a young architect, because what's happening with the technology is creating such a huge paradigm shift that is the moment that you can grab those territories back. And so I guess all I'm saying is that what SHOP is about is, and what we are calling for is for taking that responsibility and taking that risk, because I think as a profession we have so much to offer for the production of culture. Thank you very much.